Type 1 diabetes arises following the autoimmune destruction of the insulin-producing cells of the pancreas. It's often diagnosed in children and adolescents, who usually present with a classic trio of symptoms: excessive thirst, hunger, and urination, as their blood sugars spike and they need to go on insulin for the rest of their lives, since their own immune system attacked and destroyed their own ability to produce it. What would cause our body to do such a thing? Whatever it is, it's on the rise around the world, starting after World War II. Understanding why and how the current pandemic of childhood diabetes was produced would be an important step towards reversing it. A plausible guess is that of so-called molecular mimicry, whereby a foreign antibody generated like a bacteria or virus provokes an immune response which cross-reacts with a similar-looking protein on our own pancreas, such that when we attack the bug, our own organ gets caught in the crossfire. OK, so what pancreatic proteins are type 1 diabetics self-attacking? In the 80s, a protein was identified, which in the 90s we realized looked an awful lot like a certain mycobacterial protein. Mycobacteria are a family of bacteria that causes diseases like tuberculosis and leprosy, and all newly diagnosed type 1 diabetic children were found to have immune responses to this mycobacterial protein, but that didn't make any sense. I mean, type 1 diabetes is going up in the industrialized world, whereas TB and leprosy rates are going down. Well, there is one mycobacterial infection in livestock that shot up with the industrialization and globalization of animal agriculture, called paratuberkulosis, which causes Johne's disease in animals, now recognized as a global problem for the livestock industry. Weren't there like a dozen studies suggesting that exposure to cow's milk may be an important determinant of subsequent type 1 diabetes in childhood? Putting two and two together, an idea was put forward in 2006. Could Mycobacterium paratuberculosis be a trigger for type 1 diabetes? It was a compelling enough idea that researchers decided to put it to the test. They attempted to test the association of MAP, the full name for the bug, Mycobacterium avium paratuberculosis, with type 1 diabetes by testing diabetics for the presence of the bacteria in their blood. And lo and behold, most of the diabetic patients were found positive for the bug, compared to only a minority of the healthy control subjects. This evidence of MAP bacteria in the blood of patients with type 1 diabetes might provide an important foundation in establishing an infectious cause for type 1 diabetes. These results might have implications for countries that have the greatest livestock populations and a high incidence of both MAP and diabetes, like the United States. Johne's disease is what you call the disease when livestock get infected by the bug. The reason the diabetes researchers chose Sardinia, an island off the coast of Italy, is because paratuberculosis is present in more than 50% of Sardinian herds. If they think that's bad, though, the last national survey of dairy herds in the U.S. shows 68% are infected with MAP, especially those big industrial dairies. 95% of operations with more than 500 cows came up positive. It's estimated the disease costs the U.S. industry more than $1 billion a year. How do people become exposed? The most important routes of access of MAP into the human food chain appear to be contaminated milk, milk products, and meat from infected cattle, sheep, and goats. MAP, or MAP DNA, has been detected in both raw milk and pasteurized milk, infant formula, cheese, ice cream, muscle and organ tissues, and retail meat. How do we know para-TB bacteria survive pasteurization? Because Wisconsin researchers bought hundreds of pints of retail milk off store shelves from 3 of our top milk-producing states and tested for the presence of viable, meaning living MAP bacteria in retail milk, and 2.8% came back positive for live para-TB bacteria, with most brands yielding at least one positive sample, so it can survive pasteurization. If para-TB does end up being a diabetes trigger, then these findings indicate that retail milk in the United States would need to be considered as a transmission vector. Why hasn't the public heard about this research? Perhaps because the industry isn't too keen on sharing. This is from the Journal of Dairy Science. Fear of consumer reaction can impede rational, open discussion of scientific studies.